Hello everyone and welcome to this new video. So today I thought I'd make a video that might be useful to someone. Over the last few days I've been developing a 2D game just for fun, and my initial idea was to generate a dungeon randomly. So far you might say, well, that's nothing special, there are a lot of ways to create them. And I agree with you, except that my idea it was to generate a dungeon that didn't have any loading times. Let me explain. A dungeon where when I move from one room to another there is no loading of the room, so it's an integral dungeon. Now, I always seen dungeon generated in this way in 2D games. The player is in one room, goes through the door, and there's a loading screen, and a new adjacent room is generated. I don't know about you, but I don't like this very much, so I thought I had to try to create an algorithm to generate an integral dungeon without loading a screen from one room to another. Now, I know some people will say, but doesn't generating a dungeon like that this use a lot of RAM? My answer is yes, it can take up a lot of RAM if we generate a disproportionately large dungeon, but if we stick to something not excessive, we won't have any major problems. Now, the algorithm I use to generate this type of dungeon is something I have invented myself. I don't know if anything like that exists, so if there is already an algorithm like the one I came up with, well, I'm sorry, but I didn't do it on my purpose. That said, let's start with explanation of the dungeon. Okay, before starting by explaining how my algorithm work and what I figured out, I wanna say a few things. So first of all, I made this project, this algorithm in C++ with the graphic library Raylib. Yes, from the last tutorial I changed from SFML to Raylib, but it doesn't matter. And I want to say another thing. In this video I'm gonna make a tutorial more on the theory, not on the code. Exactly, I don't gonna show you a lot of code, basically because I make a huge code. I made a huge program. There is a lot of lines of code and go through all these lines. It will gonna be very difficult to explain. But I'm gonna show you also a few lines of code or some part of code that might be interesting and useful for you. Obviously, this is not supposed to teach you how to write the code, but simply I'm gonna explain you the process, the idea for make this kind of dungeon. So having said that, we can start. Okay, so we can start. Essentially, I want to start by explaining you the algorithm. So yeah, we start. First of all, my idea it was very simple. Every time that you wanna generate a dungeon, you always start by placing one room, the start room, or call in any way you want. So first of all, in my algorithm I thought about the idea to place a room in the center of our matrix, our map, or call in any way that you want, essentially. So first of all, I already explained in another video what a matrix is, but if you have not seen this video, don't worry, I'm gonna explain a little bit what is a matrix. So essentially in programming there is a thing called vector or called array. which is a sequence of elements where you're gonna put data inside. This kind of data, it might be, I don't know, numbers, characters, strings, or even true or false, or other data like, for example, in this case, the tiles of the map. So this is the simple array. But there is another array called matrix or multidimensional array, which is the same thing but is not only on the wide but also on the height. So if you take a look at this example, you can see that it's more like a map, essentially. And well, with that we can make our grid, which our grid is essentially our map, where we're gonna generate our dungeon. Every cell, every square of this matrix essentially is one tile, and our tile essentially is our map. Every tile is a texture, and the texture essentially can be, I don't know, the floor, the wall, the door, or anything that we want. Okay, so in this example I'm gonna make a map of 150 for 150, so essentially is not a very big map. And obviously with this size we cannot generate a very huge dungeon, but I only made it of these dimensions for the example. If you want to make a bigger map, you can do it. If you want to make a bigger dungeon, you can do it. For this example and explanation, I don't gonna do a very huge dungeon generation. Okay, so far we have seen what is the map. Now that we know what the map is and how it's made, we need to find the center. So we need an algorithm for find the center, and essentially this is very simple, because you need only to take the width and the height of the map or matrix and divide it by 2, and obviously you need to take this value as an integer number, not a float, because you cannot put a float value inside the index of the matrix. Well, when you have found the center, now we need to do a very simple task: generate the start room, the first room of our dungeon. Which it could be every time the same, or if you want you can make a different starting room and change from one time to another. In this way you can have different starting, but this is all on your hands. You can do everything you want. Okay, right now, before going through the process for generate the corridors and other rooms, I want to explain you the basic idea behind all this generation. The basic idea is that there is a small variable behind in the code called anchors. So the anchors in my algorithm is very important because they are essentially all the points where we need to generate a new room or corridor. I'm gonna explain better. In this case, the first room, as you can see, there is only an exit. The 2 doors are the exit, obviously. So in this case, I'm gonna save one of the 2 tiles, in particular the position, so the X and Y position of, for example, the left one door. Now that I have saved my X and Y position inside the anchors, I know where my exit is. In this case, I need to generate a corridor. So when I need to generate a corridor, I'm gonna take my anchor. I'm gonna see where we need to generate the corridor, and then I'm gonna place the corridor. So our anchors are very important for Nuit where we want to generate the rooms or the corridor itself. We'll see better later how they work, but this is the simple theory behind my algorithm. Okay, so we have the starting room, we have our anchor. Now, what we need to do? Well, simply we need to generate the corridor. And I want to explain you that there are only two possible corridors for all your dungeon. And the corridors can be straight up or straight on the right or on the left. So there is only two types, or for the north and south direction, or for the west and east direction. And there are not other kind of corridors. Obviously, you can do strange corridors that turn a certain point, but we want to do a very basic algorithm for now. So there are only two kind of corridor that we can spawn, and as you can see, with these two kind of corridors, we cover all the possibility, because essentially we need to spawn or generate a corridor on the right. Well, we have the corridor for the right and left direction, so we have done. Okay, in this case, I have to explain you another thing, that in this case there are two anchors. Why two anchors? Essentially, there is one in one side and one in another. So there are two anchors. And when we have two anchors, what we are gonna do? Because if you think a little bit, this could be a very big problem, because if from my starting room I'm gonna generate a corridor up over my anchor of the starting room, obviously I'm gonna delete the data from the anchor of my starting room, so I'm gonna erase from the memory. In this way I'm not gonna use it anymore, because this anchor is gonna be useless, because I already generated the corridor. Right now in my memory there are other two anchors. One which is the probably the closest to the old one, and another that is very far from the oldest anchor. So in this case, as you can see, one of the two anchors it will be useless, because there is the starting room and we don't want to generate another room on top of the oldest one, or in this case of the starting one. We need to generate a new room on the from the more far anchor from the oldest. In this case, what we can do? Well, essentially we can do a small check around our anchor, and this check what is? Essentially we go on the first anchor, and we're going to see if around this anchor, in the 4 tiles around the anchor, there is a tile with a specific ID. Yeah, all my tiles have a specific ID. In this way I can figure out which kind of tile are. And if the tile is a -1, there is nothing, is empty. If it's -2, we are talking about an anchor. So, you know, right now. Yeah, so if I'm gonna check and around my anchor there is a -1, I know that I can spawn something near to this anchor. But if I gonna check around my anchor and there is not a -1, I know that this is an anchor that is completely useless for me because it's the more closer anchor to the old one. So I can erase from memory this anchor and use the other one. For now, in the same time, you can figure out another thing, the direction where you need to summon the new room. Let's think about it. If you have checked around the anchor, the 4 tiles around the anchors, you have figured out also the direction where you need to summon the room. So if you check around and you found that the tile on top your anchor is -1, you have found that the direction for the next room is gonna be up. And this is not a very useless information. It really is very, very important to figure out the direction, because if you don't figure out the direction, you have no idea where you need to start to draw your room. You have no idea where you're gonna place the room, and also you have no idea which kind of room you're gonna generate, because probably from one direction to another you're gonna generate a different room in base obviously of your dungeon. Okay, so we have found the anchor where we need to summon the new room. We have found the direction, and so right now we know exactly which kind of room we want to generate. Obviously this is on your code, on your algorithm. You can do it randomly or with a, I don't know, an exactly generation. You do everything you want, but from now essentially we can redo the same thing, and from the new room we're gonna find the new anchor, generate a new corridor, from the corridor a new room, and you can do in this way for almost infinite times. You can go straight in this way and generate a dungeon in this way exactly. Okay. Wait a second. We need to try if this works. So I made a small test over there, so I'm gonna show you the demo of my dungeon generation, just for show you that it works. And then we have other 2 things to talk about, because they are very important, otherwise we cannot make this dungeon for our game. So 3, 2, 1, let's try. And it works. So as you can see, the dungeon that I generated is not really big. There are a few rooms and a few corridors, simply because I thought that it was completely useless to try to generate a very huge dungeon just for the demo. Another thing is that my player over there is not centered with the map. I need to change a little bit of the spawn of the player. Don't look at that for now. So I want to say a few things. First of all, the first problem is where we're gonna store the informations for the room and for the corridors, obviously. Try to think about it for just a moment. What is the best solution for save all the tiles, all the informations of the room? And I'm gonna explain you what is the best solution that I found later. And I want to say another thing, that right now there is a very big problem. The problem is that our algorithm is not 100% accurate. Why? Simply because right now every room can be generated on top an old one. Yeah. Because simply our code doesn't go to check if in the location where our new room is gonna be generated, if there is already an old one or an old corridor or anything else. So I'm gonna check obviously with the anchors around if there is something, but maybe it's not directly around the anchor. Maybe it can be a little bit farther, like, I don't know, 5 tiles or something like that. And so our code cannot try to check every tile in a range. So I want to say that I've not found a very interesting solution. So I leave you with the idea to try yourself to find the best solution for. I'm gonna remove this issue. The only thing that I done, not really done, but I thought, because I have not implemented in my code right now, but I'm gonna do it later, is to try to check all the tiles where we're gonna summon or generate the new room. So essentially I know where we're gonna start to draw the new tiles, so I'm going to check for all the tiles, and if I found something that is not equal to ID -1, I don't gonna generate the new room or corridor, obviously, because it means that there is already something over there. Think about that for just few moments. If you already generate a corridor and now we are trying to generate a room, but there is not enough space, we need a backup solution, because otherwise we have a corridor that sends the player on nothing, the space, in the void. I don't know. So we need to find a backup solution, say something like that, like a wall where, okay, here there is a nothing, is a fake corridor, there is a wall, you cannot go farther than this, so go back and try to find another way for, I don't know, for find the boss or the treasure, anything like that. You have understood. So yeah, my idea, it was simple to try to check all the area where we're gonna generate the new room, but actually this is, I think, that is not the best solution, simply because I need to check every tiles, and if I need to generate a room like 50 by 50 tiles, yeah, it doesn't gonna take a while. It's just 1, maximum 2 seconds, something like that. Yeah, but is not the best solution, obviously. So if you find something more interesting, more smart, leave a comment. There is no problem. It can be useful for someone and also for me, if you want to say something about this problem. But now it's time to show you the solution of where we're gonna save our rooms and corridor. Well, it will not be very simple solution, I want to say, but is also not very common, I think. I never seen this before. It was the first time. Maybe other programs or games use stuff like that. You can tell me in the comments if you already know this. But it was very interesting. Maybe it can be useful also for you. So let's find out what solution I found. Okay, so it's time to talk about my plan for store all the data of the rooms, corridor, etc. So what's my idea? Well, I want to talk of another thing before explain you my idea, and how usually these kinds of data are stored on video games. So essentially, normally we use the txt file and we are gonna put inside the map. So essentially, let's try to think about the idea that 0 is the floor, 1 is the wall. So we are gonna open our txt file, and inside we are gonna write a few ones, like, I don't know, 13, no, 13 is a lot, 10 ones in a row, and then we are gonna repeat this process for other few lines, with the exception that between the first and the last one, once there will be a 0 or a lot of zeros, because we are gonna put the floor. And so in this way we are gonna make essentially a room. Every one of these numbers, it will be a tile, a different tile, the floor and the wall we've said. And this is not really a stupid idea, because we can store a lot of data in this way. But let's try to think about for a few seconds. How can we get the wide and the height of this room, for example? We know the wide and the height, but the program no. So every time for check if the wide or the height is enough for the space that we have for generate the new room, we need to go through all the numbers with a for loop, for example, and search for every number until the last one. And when we are come to the last one, now we know the wide of the room. Then we need to repeat this process for the height. And in this way, okay, right now we know the wide and the height, but right now our program is searching for a specific area, and this room it doesn't fit this area, so it's bigger than the area that we have. We need so to check for another room, and we do the same thing. Later our algorithm want to generate a new room, another room. So again we need to open this file, again try to find the wide and the height of this room, and then check again if the area is enough for fill the empty space. So this process is very long, and try to check this value every time. It could be very boring. Okay, we can do a few things, like save, I don't know, 2 lines before the map, and say that the first line is for the wide, the second line is for the height, then we are gonna leave an empty line just in case, and then we are gonna put our map. But I don't know you, but I'm not very fan of the use of ifstream. I don't like very much take data from ifstream. It's not very complicated, I know, because you can use the get line, but I don't like so much the use of ifstream and offstream. In C, I think that is worse than C++, but I don't want to say that one thing is terrible than another right now. So I'm not a very big fan of files. So do this all the time, it could be very boring. Okay, I want to say another thing, that is, in one file can be only one room. So if we want to make another room exactly the same, but with a little change, so the width is the same, the height is the same, the type of room is the same, but we know, I don't know, want to put only another exit from the room. We need to make a new file, try another name, find another name, and do the same thing. Okay, this is not a very huge impact on the memory because there are only 1 kilobyte or 2, so it's not a very big data. But the problem is that we need to open the file, so we need to know the path of the file every time, and this will be our problem. So I don't wanna lose in talk for a lot of time. I want to explain you what is my solution. So my solution essentially is to use JSON. And probably someone can ask me, Red, what the fuck are you saying? You can use JSON with C++? Yeah, exactly. You can use JSON with C++. Probably maybe someone doesn't know what JSON is, so I'm gonna explain you a little bit what it is. I wanna take only a few seconds. So JSON is a lightweight data interchange format. It's a human, readable, and easy for machine to parse and generate, making it ideal for transmitting data in web applications. And no, trust me, I have not read it online. No, yeah, I search on Google. But well, essentially JSON, it was made only for JavaScript, which is a language that you use on a website. Blah blah blah, it doesn't matter. Okay. So essentially only JavaScript technically can use JSON. No, it's not correct, because there is a library of C++ that integrate JSON, or more specifically, the use of JSON. And right now, I don't remember the name of the library, so I'm gonna put it over there, the name or the link of GitHub, because actually I don't remember right now the name. So how this works, how can you install this library? We need to make a very complicated thing with CMake or something like that? No, essentially we need only to go on GitHub, on the GitHub repository, and download the HPP file. Then that is the normal h.h file of C++. Then when you have downloaded, you take this file, drag on your folder, leave there, and you have done. You're gonna include it where you need to use JSON, and simple. So essentially right now I'm gonna show you a small example of use of this JSON over there. So with JSON, I don't gonna want to explain how JSON works, because it's very simple, but I don't want to lose in talk. So I'm gonna say that this example is more simple if you know JSON. If you don't know JSON, I think that is also very intuitive, but if you don't understand very well JSON, well, I'll try my best for explain, but I'm not sure. So essentially, as you can see, every item here, I don't know if the correct name is item, but I'm gonna call it item. Every item inside here, the JSON, is surrounded by these curly brackets, and then there is a comma brackets over there, which allows us to put another one, and allow us to put another one only if we are inside the square brackets. So essentially this is an array of items. Okay, now we're gonna take the first one. So inside there are a few things. The first one is the name, which I call it generic room, is not important. Then there is the ID that I use for choose randomly the room when we need to generate it. Then there is the type, which is a room. I use the type essentially for check if I want to generate a room or a corridor. So if I need to generate a room, I'm gonna find the item which is type is room. Otherwise, I'm gonna search for the item which type is corridor. Then we have the wide and high. And so right now we don't need anymore to search for all the items and find the wide and the high. And then there is a big matrix, as you can see, which is the same of the old one that I already show you. And nothing. That's all. So we can repeat this process for all the rooms that we want. All the rooms in only one file, but you can make different files. For example, you want to make, I don't know, a specific room with a treasure. You can make maybe a different file because it's more simple for you to understand where it is. Or maybe for the boss room, you can make a different JSON file. Yeah, obviously it will be better in this way. But you can make here a lot of rooms all in one JSON. Crazy. Okay, but wait. Red, how can we get this data inside our C++ code? Because here we are inside the JSON. How can we get these values, this data? Well, it's not simple at first. But when you have understood, it's not very complicated. So follow me, I'm gonna show you right now finally the code. Not very deeply, but only for how can you get these values and this data from the JSON. Okay, well, I don't want to take a while by explaining how JSON works with C++, so I'm gonna be a little bit fast, but I'll try to do my best for explain you very well how this code works. So first of all, in the first few lines essentially are only for take the JSON file as an input. So there is an if stream where we are gonna take start.json as a file. Yeah, I take the code for generated the first room of the dungeon, but it's the same for all the other rooms. Then I go to check if the file is open, obviously, because otherwise I have an error. So if the file is not open, I'm gonna send an error on the terminal. Otherwise, I have some function of debug for the game, but we can ignore this. Then I'm gonna create an object called add.j, which is an LOHMANN JSON. I don't know how to say this name, which is our JSON item. Then I'm gonna send all the data from the JSON file to the J, and then I have an item, rooms, which we're gonna see later what is. Dot name, so rooms dot name essentially is a string, so I'm gonna take from j dot at the id name dot get std string. What this means, so essentially in the start.json there are not other rooms, so I'm gonna put it over there. So as you can see, there are not other rooms, so there is only one item inside the JSON, and it's very simple to get this item, but we're gonna see later how can we do it for more items inside the JSON. So we can simply say I want to take the name, so I'm gonna search for the key name, and I want to get the value as a string. So the return essentially is a string. Then I'm gonna search for the type, which also is a string. The wide and the height, I want it as an integer number. Then there are 2 lines for put the room in the center. And then there is all the code for get the tiles, our matrix inside the JSON. Well, it's not very complicated. Essentially there is a for each loop, as you can see, which I'm gonna say that I'm gonna take from tiles, from the key tiles, a copy. Then there is an ID as a short. Essentially it's only for check the ID of the tile is -1 or 1, 0, etc. Then I'm gonna copy the center on another X. This is only for placing the correct spot, the room. Then there is another for each loop, which I'm gonna take a copy from row_JSON. So in this way I'm gonna take the height. Essentially is like doing a double for loop, but with the for each loop. I'm gonna take the ID tile as a short value from our tile.json. And then I'm gonna check for the texture. I'm gonna place the tile. I'm gonna set the ID. I'm gonna check if it's equal to 5. If it's equal to 5, that means that is an exit. So I'm gonna save a new anchor. I'm gonna increase the X and the Y. I'm gonna repeat the process. When I finish this double for each loop, I'm gonna close the file. Essentially I can do it also before, but it doesn't matter. And then there is a small do while loop for generate all other rooms, but it's very simple. Okay, so I'm gonna show you right now the example if we have more items inside our JSON file. So the code essentially is the same. I have not put the code, but forget the input of the JSON file is the same thing. So again we're gonna make JSON item, and then I made another item called final JSON. I'm gonna take as an input all the items that are inside file. I'm gonna put it inside J, and then I'm gonna check if J is an array. So if it's not an array, that means that inside the JSON file there are not more than one item. If it's an array, obviously it doesn't go inside. Then there is an int random val. This essentially is for generate a random room from all the rooms that I have inside the JSON. And don't look at direct. Essentially it's for direction of someone of the room, is not important. And also the round value and possible rooms. These lines are essentially for choose which room I'm gonna generate and choose it randomly. Then there is a for each loop again, where I'm gonna take from all the items one item, and I'm gonna choose in this case that if map obj contains an ID and the ID is equal to 1 or 3 or 5 in this case, Then I'm gonna take this object and gonna put inside this item, this JSON item, I'm gonna put inside the final dot underscore j, and then obviously I'm gonna break the for each loop. So in this way, with map obj, I'm gonna throw all the items inside the array of JSON, and when I found the item that I'm interested, I'm gonna save it. And then obviously rooms.name and etc. Rooms.type, width and height are the same of the ones that I already show you, with the difference that this time is not j but it's final underscore j. So it's the same thing. Well, we're come to the end of this video. I told you everything that I thought about my algorithm for generate this dungeon. I don't know if this video can be useful for someone, but I was interested on share with you this algorithm that I made and that I thought. I want to repeat again that if for some reason one algorithm like that already exists, I'm sorry about that. I was not knowing, and I currently don't know if an algorithm like that exists. In case, I'm sorry, it was not my intention to copy it, essentially. Well, so for this video is all. Thank you for watching. See you next one. Bye bye.